All right, welcome back. In this video, it occurred to me I didn't actually plug these two solids into the calculator to compute them, the square and the semicircle parts A and B. We just did the setup on paper, which is, the big conceptual hurdle for this stuff. But I know some people could use a little help too with how to best use your calculator for this stuff. So we're going to go through that in a second here. I will also mention I added in with text a couple of the things that I had handwritten before to make them a little neater. So I did fix the limits of integration of C and D here. And I've got the inverse functions defined clearly up here. Again, if you want to use this kind of notation in your work on a test, on the AP exam, for example, you do need to clearly define any functions that you use by name if they weren't given. That's important. I also put in I typed in the intersection points here too. That was the first thing we did with this, was to find those intersection points so that we could use them for our limits of integration, right? So we have, A and B here. A and B here on our first one for the squares, right, for F minus G. So we're going to go ahead and put that in the calculator now in the TI-84. Keep in mind we have F and G in there. They're in as Y1 and Y2. So, and as you can see here, I've stored A, B, C, and D. I've stored the X and Y values of those limits of integration. So what I'm going to do is on this main screen, I'm going to do that integral. If you go to Math, the Math menu on the TI-84, it's choice 9 here. Math 9 gets this integral. And I want to go from A to B for that first one, right? If we look back at our work here, in A here, the squares perpendicular to the x-axis, I want the integral from A to B of f of x minus g of x squared. So from A to B, I'm actually going to put A there. So alpha and then math is where A is, and then right next to it, alpha apps gives me B. And then in this parentheses, I want f of x minus g of x quantity squared. And they're in as y1 and y2 respectively. So I'm going to do y1 minus y2 quantity squared. I need another set of parentheses in here. You need it because that outer set of parentheses, the one that were already there, those are immutable. You can't change that, and you can't put a square on the outside of it. Whatever's going to be integrated has to go in that parentheses. And I need the difference between f and g squared, right? I need f of x minus g of x quantity squared. And so on the calculator, we're going to have that extra set of parentheses outside of the square there. So it's important to understand that as you're putting it in. So I opened a new set of parentheses there. And then the best shortcut for getting y1 is just alpha trace. It's the F4 menu. And I'm going to do enter for y1, or just 1, either way. And then minus, and then y2. So alpha trace 2. And then end parentheses squared. Okay? And then out here, I'm going to put dx. And I'm going to hit enter. And there's my volume. It is 7.073 for the first one with the square cross sections. All right, I'm going to do the same thing now, same kind of thing for B, the semicircles. But here, this is it's a little different, right? I have G inverse and I have F inverse. And I need those functions. My calculator, the TI-84, doesn't do algebra for me, right? And so in order to get those functions, I am going to have to type them in, all right? So my functions are right here, right? F inverse is e to the y minus 2. I'm just going to put it in with x's. On the calculator, I just only use x's for my variable. So I'm going to do y3 is going to be, actually, I might make y3 be g, because that's the one on the right. So when we're going horizontally, we're taking the g curve minus the f curve, right? And so I like to, I usually do like y1 minus y2. I'll do y3 minus y4. So I'm going to put in g first. And as y3, I'm going to put in x to the 1/3 power plus 1. So cube root x plus 1. So let's do it. Under y, go down to y3. and x to the 1/3 power. Do it like this. You can do the fraction tool in there, whatever, that works. Oh, whoops, it was +1, right? And then for y4, I'm going to do f inverse, which was the e to the y minus 2. So I'm going to do second natural log there to get e to the, and I'm going to put in the y minus 2, but again, with just x minus 2. I'm using x as the input to these functions, and because it does not matter what variable you use in the integral, as long as you're consistent, as long as your variable in the integrand matches the variable in the differential, it'll come out right. So I'm going to do math. Actually, before I do that, before I do the integral, it's pi times the integral, right, on this one. This is semicircles. So I have pi over 8 out front, that coefficient. Let's put that on there. So start with that and do alpha y equals to get the fraction tool. Hit enter. And pi over 8. And then math 9 for the integral. And I'm going to go from c to d this time, right? Because now I'm using the y values as my limits of integration. So c up to d. And now I need g inverse, which was y3, minus f inverse, which was y4, and squared. So again, parentheses so that I can square it. And alpha trace 3 minus alpha trace 4, end parentheses, squared, and now dx. And you might be thinking, oh, it's dy. Yeah, it's dy if my input variable is y, but y3 and y4 that I just put in there have input variable x. And so what's going into it is x, so I want to be consistent. And so now when I hit enter, this should give me the volume with the semicircle cross sections, and there it is. It's about 2.065. So if I needed an answer, that's what I would do. And if I was going to do the computations on all of the solids we do, it's going to get super repetitive, and I'm going to be able to reuse code, right? Next time I do one that's vertical, I can just go back up to this one and hit enter and recycle it, and all I need is a different coefficient, right? It's still going to be, you'll see in a minute, it's going to be an integral from a to b with those functions squared. It's just going to be, depending on the shape, multiplied by a different value. For semicircles, we saw pi over 8. In the next video, we'll look at some different triangle cross sections.